900 square meter of trekking area, 123 gigabytes of raw data, day and night of effort in data mining. Now, here we go!
Now let me talk about the distribution visualization. We consider in total 42 days of data, and in each day, we divide the whole area into small grids, each with 0.1 square meter, and analyze the statistics inside each grid of the day. Firstly, we analyze the number of person time shown in each grid. Obviously, weekend has more people. Well, the interesting thing is on weekdays, there is an invisible path where more people tend to work on it. The path doesn't exist in the mall. People tend to work on it because more people in weekdays are mainly working through, and they will choose the shortest route to work on, which formed the invisible path. The speed analysis, where we calculate the average speed in each grid, also shows that people on this invisible path tend to work faster, so we shouldn't put any obstacle on this path to make the best working comfort of the pedestrians. Here, we use the k-mean clustering to divide speed into 5 clusters from very fast to very slow. And as we can see, people on Sunday tend to work slower. Then we use Spark and do k-mean clustering by the position x and y of each person time to divide the mall into 10 areas. We suggest the mall to assign safeguard at the center of each cluster to minimize the average distance to each client. After that, we use Peak to filter out the working customer by velocity and analyze the working direction of them. We do that by calculating the average motion of angle in each grid. We find most people are really polite, which means most of them work on the left in the corridor. Well, the interesting thing is, people tend to be politer on weekend, for the working direction is more clear on weekend, so we may now need more security staff on weekend. That's a good news for the security staff, right? Then we filter out the still customer by speed and analyze their distribution as we did in the first part. We made a match between the popular areas and facilities on a Sunday in January the 6th, when there is an event in the south part of the mall. We found on weekend the information desk area is very crowded, and the shop tend to be more appealing than the shop good display. We also find that the invisible path area in the right cycle don't have much people to stand by even in the weekend. This is sort of waste of the area. Finally, we filter out children by height and draw their distribution. We found children seldom come on weekdays, and they mainly stay at the bench and shop good area. So for the children promotion and security, we should mainly focus on these two areas and on weekend. Based on this, we may come out some suggestions. Firstly, for the flyer sending and sales strategy. On weekdays, the flyer senders can stay beside the invisible path shown in the right area and advertising the business-related service. On weekend, promotion can happen on the circled area or good display side of the corridor to attract shoppers and avoid congestion. Children's sales should mainly happen on weekend at the shopping goods display area and the bench area. For the security strategy, it is good to set the security staff at the center of each cluster to minimize the distance to each client. And we don't really need more security staff on weekend because people tend to be politer on weekend. Also, the security staff should pay attention to the good display and bench area to protect our lovely children. Finally, for the commercial installation, the shopping goods display attracts few people, so we can replace it by the shops. And also we should put more shops in the red areas inside the invisible path. Also, we need more staff in the information desk, especially on Sunday or in the event days.
Now let's take a look at pedestrians' group behavior analysis and classification using Mahout. As we know, group and individual shoppers are different in many ways. They buy different products, and their tolerance for interruptions are also different. Usually, group shoppers are more friendly to flyers and questionnaires. From research, we learned that pedestrians are considered socially interacted while they walk towards a common goal, and at the same time, they want to keep the goal and their partners in their vision field as well. These pictures show the relation between their vision and motion angle for 2 pedestrian and 3 pedestrian systems. So, by knowing their motion and facing angles, we can classify our pedestrians in ATC shopping mall into group and individual shoppers. Now let's see how can our dataset help. Researchers from 3D range sensor team manually denoted group information of pedestrians in part of the shopping center, which is shown here. We used Python to pre-process our dataset and selected those people who appeared in this area by their x and y coordinates, and also append their group information at the end of each row. We then use a big data visualization tool, Network X, to plot the data. The plot was laid out using FR force-directed algorithm. This algorithm will ensure larger groups in the middle and smaller groups and also individual shoppers at the peripheral. In these figures, the red nodes denotes group shoppers and blue nodes denotes individual shoppers. After analysis, we found the proportion of group shoppers are around 30% on Wednesdays, and it is around 52% on Sundays. Most of the groups have 2 to 3 people. We then did classification using Mahout. The classifier we got uses 2 predictors, walking angle and facing angle, as introduced earlier. The model we got is shown here. By using this model, we can know if a pedestrian walks in a group or he is walking on his own. Now it's the time to apply our results. Firstly, we suggest restaurants in ATC shopping centers setting up more single tables on weekdays and more larger or couple tables on weekends. Also, we suggest promotions of couple and family-related products can be done more on weekends instead of weekdays. Besides, we found that ATC is now trying to send flyers by robots. In this case, we suggest those robots learn our Mahout classifier and target those people who works in a group, because groups are usually easier to accept flyers. In this way, the process of sending flyers can be much more efficient. Our Mahout classifier can also be applied to criminal detection. The policeman can filter out individual pedestrians to solve a group crime case in ATC shopping center.
Here, let me show you our first approach made on analyzing pedestrian flow rate over time period. The pig was mainly used in this application on grouping, filtering, and counting. Here, let me show you a quick demo about how we utilize the pig in this session. Here is the raw dataset for a single day. Each column represents time, ID, positions, height, velocity, facing angle, and motion angle. The last column represents a time identifier, which we add there by using Python. There we specific 40 time period to calculate the flow rate. Here I'm already in the pig shell, and I'm just gonna copy paste each command into it. First load the data, and then group the data by time period, and after that count ID in each group, and finally dump the data. Here we can see the result is already showing here. I'm just waiting for this process to complete. And this should take a while because our dataset contains thousands and thousands of lines. And that's why we use a pig in our application, because pig has MapReduce and which can improve its efficiency. If we use other tool, it will take much longer time. Here we see the process is already done, and I'm just gonna show you how the result look like. So the first column is the time identifier, and the second column represents the relative flow rate, which come from the ID count. After we got this data from pig, we can put them into a visualization tool. here called Intersoft. Here I'm just going to show you a visualization I already created with full data. Each line of this plot represents the flow rate of a single day, which is counted by using pig. Now go back to our original web page. Here is that graph again, from which we can see that the flow rate on Sunday is obviously greater than that on Wednesday, which is also known by nature. However, we also find the main difference happened during the afternoon period, from which we can suggest the shopping mall have more service staff during Sunday afternoon rather than Sunday morning or night. Here is a column plot showing that the average flow rate on Sunday is about twice as much as that on Wednesday. Then we also took our second approach on analyzing the flow rate difference between event day and non-event day. We specified the target area of Southern Stair region for this study. The stair leads outside to a wide space in front of the mall, where sometimes is used for different events. By utilizing the similar method as I talked before, we generate this plot, from which we observe there is a distinct peak during the morning in the January 6th. Checking the event schedule in ATC Mall for past years, we found that the Osaka City New Year Firefighter event was on that day, from 10 to 12, which confirmed our expectation. These are very useful information for event planner so that they can refer to predict the flow rate of the shopping mall in specific region, so that they can plan for the security guard and service staff.
Thank you for listening, and thanks for the course.